modified Atwood machine, no friction. Cart has a frictionless bearings and the green hanging mass falls. The green hanging mass loses potential energy. Potential energy becomes two kinetic energies. One is the green hanging mass's kinetic energy. The other is the red cart's kinetic energy. If the red cart has a mass 6 kilograms and the green hanger is 4 kilograms, the green hanger falls 2 meters. How fast does the hanger strike the floor? Conservation of energy will let us deal with this without issue. No friction, so there's no energy dissipated. Both objects start at rest, so we don't have any kinetic energy in the beginning. We can ignore the cart's potential energy because it doesn't change, and energies that don't change affect the result. So this cart is not changing heights, so we won't say the gravitational potential energy of the cart, even though it's definitely elevated. But because it's not moving up or down, we don't really care about the gravitational potential energy here. So we have the hanger's potential energy becoming two different kinetic energies. Good. Plugging in. We got two different V's. Are they different or are they the same? If there's no friction, they're the same. So we get velocity is 4 meters per second. Hard part here, I would say recognizing to use conservation of energy. It's not a hard part, though, if conservation of energy is your go-to. Just go to it. Now if we introduce friction, so now we have the red cart 6 kilograms replaced by a red block, and there's a coefficient of friction of 0.5. Green hanger is 4 kilograms, and it falls 2 meters again. How fast does the hanger strike the floor? So now we have energy that's been dissipated. We have this force times displacement. The distance the red block slides is the same as the height. Do you see that? It has to go the same height. It just does. So D equals Y. Friction force is mu times Fn. And Fn on the block, because it's a flat surface, is just the weight. So again, there's friction, and I have drilled into you to go to your free body diagrams. So your free body diagrams here are going to be useful for you because we need to know what is that friction force. Both objects start at rest, so there's no kinetic energy, ignoring the block's potential energy because it doesn't change. We have the hanger's potential energy becoming two kinetic energies and a dissipated energy. Plugging in all of the numbers, we get V equals 2 meters per second. That's a really complicated situation. And to me, I don't feel like this is a very difficult process to do. So you can use this to get yourself out of some crazy situations, for sure.